So, picture this. It's 1898, and there's this massive crowd at Madison Square Garden,
Right.
and they are all just staring at a pool of water. And in this pool is a heavy metal boat that is somehow steering itself.
With no wires attached whatsoever.
Exactly. No wires, no pilot sitting at the helm, just this heavy metal thing moving on its own. And according to the historical records from that day, the crowd's first instinct wasn't to, marvel at a technological breakthrough.
Oh, not at all.
No. They genuinely thought the inventor was using telepathy to move it, or, and I love this detail so much, that he had somehow trained a tiny monkey, right, and hidden it inside the hull to steer.
A tiny monkey. I mean, it perfectly captures the sheer gap between the public's understanding of reality at the time and the reality this particular inventor was already living in.
It really does. Like, when society encounters something that is decades ahead of its time, the human brain just defaults to magic or monkeys, I guess, because the truth is just too difficult to process.
It's just foreign.
So, welcome to a brand new deep dive, everyone. We're so glad you're here with us. We've got an incredible stack of sources on the table for you today.
We really do. We're looking at a huge collection of biographical excerpts, original patent summaries, and historical engineering records.
And our mission today is to separate a very famous myth from a very, very complicated man.
Because for you, the listener, if you were the name Tesla today, your brain probably immediately jumps to, well, the car company.
Right, or a certain tech billionaire constantly on the news.
Exactly. But we want to ground this conversation in a core belief based on our sources. And that is, if you look at Thomas Edison, right, Edison was a developer.
A brilliant one, to be fair.
Oh, absolutely.
Right.
He invented products, he took ideas, refined them, and made them marketable commodities.
Yeah.
But Nikola Tesla, the actual man born in 1856 in Smiljan, which was then the Austrian Empire.
Known as now Croatia, right.
Right. Tesla was a true visionary who thought entirely in ecosystems. He wasn't trying to build a better light bulb. He was trying to build the invisible infrastructure required to light the entire globe.
And we are going to explore how he literally built the modern world that's humming beneath your feet right now. And, sadly, why his most science fiction level ideas were ultimately crushed.
Yeah, it's a fascinating kind of tragic story.
So, to understand his genius, we first have to understand the flawed, honestly clunky world he was trying to fix. In the late 19th century, electricity wasn't this, seamless, invisible utility that we know today.
It was a very messy, highly localized experiment.
Right. And that brings us to the famous War of the Currents.
Which fundamentally decided how human civilization would be powered from that moment forward.
Okay, so Edison had championed direct current, or DC, and according to the historical records we have here, DC had a fatal flaw when it came to actually scaling it up.
Yeah, the voltage drop. The electricity would lose its strength incredibly rapidly over distance because of the resistance in the wires.
So Edison's vision for an electrified world meant building a coal-burning power plant pretty much every single square mile.
Just a logistical nightmare.
Right. And connecting everything with these massive, incredibly thick, expensive copper cables.
You simply can't electrify a massive continent if you need a smokestack on every other street corner just to push the current a few more blocks. It's just not viable.
So Tesla comes along and proposes alternating current, or AC. If we think of electricity like water, Edison's DC system is like forcing a city to build a massive, expensive water tower on every single block just to get enough water pressure to the houses right nearby.
A great way to visualize it.
But Tesla's AC system is like a high-pressure municipal water main, right? One that can supply the whole city from one distant, massive reservoir.
What's fascinating here is how the actual mechanism works. If we understand it, look at how the energy moves. Direct current is like water flowing continuously down a river to turn a waterway.
Yeah.
It only goes in one direction, so you need a massive constant flow of new water to keep the wheel turning. But alternating current, as the name implies, periodically reverses its direction. There's a foundational frequency math to this.
Oh, right, the equation from the patent notes.
Yeah, F equals 1 over T. Frequency is the inverse of the period. The current is pulsing back and forth.
So instead of a continuous river, it's more like a two-man handsaw.
Exactly. I love that analogy. With a two-man handsaw, you don't need a continuous flow of new metal passing over the log. You just push and pull the exact same saw blade back and forth.
You are using that rhythmic back and forth energy to do the actual work.
Right. And because the current is constantly alternating back and forth, it allows the electricity to interact with magnetic fields inside a transformer.
Which means you can step the voltage way, way up for the journey.
Precisely. You step the voltage up to massive high pressure levels to shoot it across hundreds of miles of wire. That drastically reduces the energy loss.
Yeah.
And then once it reaches a town, another transformer steps that voltage back down to a safe, low pressure level so you can use it in your home.
It's so elegant. But of course, Edison had heavily invested in his DC patents, and he did not take kindly to a better idea disrupting his business model.
No, he did not.
The sources detail a completely ruthless smear campaign. I mean, Edison went as far as publicly electrocuting stray animals.
Yeah, it's pretty dark.
He did it to try and convince people that Tesla's alternating current was too dangerous for public use. We're just reporting the historical record here, but it was a brutal corporate war over the future of infrastructure.
It was incredibly bitter. But ultimately, physics and practicality won out. Tesla teamed up with the industrialist George Westinghouse.
A huge turning point.
And their ultimate victory was building the first major hydroelectric AC power plant at Niagara Falls.
That proved definitively that you could generate power in one centralized place, right? And safely electrify entirely different cities miles and miles away.
Exactly. And what's fascinating here is that today, practically the entire world uses AC grids. Every single time you plug a charger, a lamp, or laptop into a wall socket anywhere on Earth, you are tapping into Tesla's ecosystem.
It's mind-blowing when you think about the scale. But delivering invisible electrical power to a plug is, well, it's only half the battle.
Right.
Okay, let's unpack this. If you want an industrial revolution, how do you turn that invisible alternating current into physical, mechanical work?
You need a motor.
Right. How do you make it spin a factory fan or pump water or move a train?
And that was the massive hurdle. Older electric motors of the era were notoriously inefficient.
The sources explain that these older motors relied on things called commutators and brushes. Basically, they required physical metal contacts inside the motor that rubbed against each other to transfer the electricity to the spinning part.
And because they were constantly rubbing at high speeds, they smelled like ozone, they sparks nonstop, they wore out quickly.
And they wasted a ton of energy through friction.
Right. Exactly. Tesla hated physical limitations. The thick copper wires of Edison's grid were a limitation, so he bypassed them with AC. The friction of the brushes in a motor was another limitation.
Because physical friction is the enemy of any machine.
So he had to figure out a way to bypass this physical connection entirely.
There is this beautiful anecdote from the biographical excerpts. Tesla reportedly visualized an entirely new type of motor, fully formed, in his mind while he was just taking a walk in a park in Budapest.
Just drew it in the dirt with a stick, according to the legend.
Right. He didn't just tweak the old sparking design. He reinvented it from scratch. But how do you make a heavy metal rotor spin at high speeds without actually touching it? What's the magic there?
Well, there's no magic, just brilliant physics. He used a magnetic cushion. Instead of sending just one stream of AC power into the motor, Tesla designed a polyphase system.
Okay, polyphase.
He sent multiple alternating currents into the outer ring of the motor, the stator, and he slightly offset them in time.
Oh, like perfectly timed waves at a stadium?
Exactly. Like the wave at a baseball game. By spacing out these pulses of electricity, he created a rotating magnetic field.
So the magnetic field itself is spinning.
Right. If you connect this to the bigger picture, it all goes back to Faraday's law of induction. That classic math principle, electromotive force equals the negative rate of change of magnetic flux over time.
The E equals negative d phi b over dt equation from the notes.
Exactly. Changing magnetic fields create a current, and vice versa. If you've ever tried to push two opposing magnets together and felt that invisible cushion pushing back against your hands?
Yeah, that weird resistance.
That's the same invisible force Tesla harnessed. He figured out how to make that invisible magnetic cushion run in a continuous circle around the inside of the motor.
Wait. So instead of moving the metal parts to create power, he's moving the invisible magnetic field to drag the metal along with it. He basically turned the motor inside out.
He absolutely did. That spinning magnetic field reaches across the empty air gap. No wires, no brushes, and essentially grabs the inner metal rotor, dragging it in a circle.
That is wild.
No physical parts are rubbing together to transfer the power. By completely eliminating that physical friction, humanity was suddenly able to build industrial machines that could run indefinitely with almost zero wear and tear.
Which is why the AC induction motor, which he patented in 1888, is the absolute backbone of industrial civilization today.
It's everywhere.
It's the reason modern factory machinery works. It's what spins the compressor in the refrigerator sitting in your kitchen right now. And yeah, it is the exact technology sitting in the drivetrain of modern electric vehicles, which is literally why Elon Musk's company is named Tesla.
It's his motor. So look at what he's done. He removes the limitation of distance with AC power. He removes the limitation of friction with the induction motor. You can really see his overarching philosophy forming here.
He is systematically stripping away the physical barriers of the 19th century.
Which brings us to his next logical leap. If the wires and the friction were limitations, what happens when he looks at the concept of a physical connection itself as a limitation?
Right. We move into the 1890s, and Tesla starts playing with things that look like pure science fiction to Victorian crowds.
He moves from mechanical power into high-frequency wireless phenomena. He starts exploring what happens when you push electricity to its absolute extremes.
So in 1891, he invents the Tesla coil. It's a resonant transformer circuit that creates incredibly high voltage, high-frequency alternating current.
And he used this to put on a show.
Our sources note he was using this to light fluorescent and neon tubes, which, by the way, he also helped pioneer completely wirelessly.
Right in front of an audience.
Yeah, he was doing this at public lectures, just walking around on stage holding glass tubes that magically glowed in his hands with no wires attached. He was pulling ambient electrical energy right out of the air.
And he even scaled this up later at his laboratory in Colorado Springs. He was creating 40-meter-long electric sparks.
Basically his own localized lightning.
Effectively, yes. And wirelessly powering hundreds of lamps planted in the dirt miles away from the generator.
And this brings us right back to that Madison Square Garden crowd in 1898. He unveils the teleautomaton, the remote control boat.
The world's first remotely operated vehicle.
We mentioned earlier that the crowd thought it was magic or a hidden monkey, but I want to push back on this a bit. Why is society's first instinct to assume a magic trick rather than accept a technological leap? Why couldn't they grasp it?
Well, because it completely broke their existing framework of reality. You have to remember, the idea of invisible waves carrying complex instructions through the empty air wasn't just a new concept. They entirely lacked the vocabulary for it.
Because wires were the only way cause and effect happened over distance back then.
Exactly. What Tesla was doing wasn't just inventing a neat remote control toy. He was simultaneously giving birth to modern wireless communication, early robotics, and autonomous systems.
All at once. And sadly, he got totally robbed on the credit for the radio communication part.
He really did. Guglielmo Marconi is the name most people associate with inventing the radio. Marconi won the Nobel Prize, he got the fame, and he built a massive commercial empire on the technology.
But the historical patent records are very clear about the timeline here. Tesla filed the foundational patents for tuned radio transmission in 1897.
Which is 2 years before Marconi's famous demonstration.
It wasn't until 1943 that the U.S. Supreme Court finally overturned Marconi's patent and restored priority to Tesla. But by then, I mean, the history books were already written. Marconi was a household name, and Tesla had just died.
It's a recurring tragedy in his life. He was a pioneer who built the foundational ecosystem, but he rarely reaped the commercial rewards of his own discoveries.
Which perfectly sets up his most ambitious and ultimately disastrous endeavor. Sending wireless signals to a little boat was revolutionary. But Tesla, being a true systems thinker, wanted to scale this concept to its absolute physical limit.
He didn't just want to send a few wireless signals.
No, he wanted to beam wireless power to the entire globe. Here's where it gets really interesting.
The Wardenclyffe Tower.
Yes. Built between 1901 and 1902 on Long Island, this was a massive 57-meter tall tower with a 55-ton hemispherical dome on top. His vision was to use it as a massive planetary pump.
He wanted to inject electrical current directly into the Earth.
Right.
The concept here is fascinating. He believed the planet itself, specifically the ground and the upper atmosphere, could act as a giant, naturally occurring conductor.
If you pump enough energy into it at the exact right resonant frequency, you create standing electrical waves.
Right. Think of it like dropping a massive boulder into a perfectly round pond. The ripples travel outward, hit the edge, and bounce back.
And if you keep dropping rocks at the perfect tempo, the waves amplify each other.
Exactly. Tesla thought he could do that with the Earth's electrical charge. The idea was that anyone, anywhere in the world, whether they were in Paris or the middle of the Sahara Desert, could just stick a tuned receiver into the ground and draw down electricity.
A truly global grid of free, universally accessible power. No cables, no power lines stringing across the continents. I want you, the listener, to really think about this for a
Oh,
second.
that's a staggering thought.
You are likely listening to this on a device powered by a lithium-ion battery that you have to constantly plug in and that you have to pay a utility company to charge. Imagine if the actual air around you right now was just humming with free energy.
No chargers.
No power bills, ever. So I have to ask, was Tesla just a terrible, naive businessman, or was he operating on a moral plane that capitalism simply couldn't accommodate?
Well, if we connect this to the bigger picture, that exact concept of free energy is why the project died. His main financial backer for Wardenclyffe was J.P. Morgan, the absolute titan of Wall Street capitalism.
Right.
Morgan initially gave him $150,000 because Morgan thought he was funding a transatlantic radio system to beat Marconi's telegraph monopoly.
Morgan wanted a communication system he could control and charge people to use.
But when Morgan realized Tesla's actual plan was to broadcast unmeasurable free electricity to the entire human race, he immediately pulled the funding.
Yeah.
And he used his influence to ensure no other Wall Street investor would touch it either. No investor would back a product they couldn't sell.
I mean, if you're Morgan, you've just spent the last few decades building the 20th century on a foundation of railroads, coal, and copper wires. Now, this visionary wants to bypass all of it and turn the actual dirt of the earth into a giant free battery.
Of course, he pulls the plug.
You cannot put a meter on the ground and charge a monthly fee for it. So the tower was abandoned, the creditors moved in, and the structure was eventually demolished for scrap metal in 1917.
It perfectly illustrates the clash between systems thinking and product thinking. Tesla's greatest strength was imagining futures that advanced the entire human species. But his fatal flaw was ignoring the reality of the profit-driven world he lived in.
Right.
In the industrial age, if you can't monetize an infrastructure project, it simply does not get built no matter how much it might benefit humanity.
And the destruction of Wardenclyffe completely broke him financially. It was a massive public humiliation. But it couldn't stop his mind from working.
He spent his final few decades living in a series of New York hotels, sketching out a science fiction future that he just couldn't afford to build anymore.
And some of these ideas from the sources are chillingly accurate.
They read like 21st century technology predictions.
Yeah. In 1909, and again in an interview in 1926, he described what is essentially the modern internet and the smartphone. He predicted that the Earth would be converted into a huge brain and that people would carry small devices in their vest pockets that would allow them to instantly transmit messages, news, images, and voice worldwide.
Regardless of distance, decades before the invention of the transistor, let alone the microchip, or the first clunky computer.
It's incredible. He also proposed manipulating the ionosphere to create rain in deserts and a system of terrestrial lighting that would use atmospheric electricity to make the entire night sky glow so cities wouldn't even need streetlights.
And the bladeless turbine, in 1913, intended for geothermal power.
Right. But then we get into the really wild concepts. Let's talk about the thought camera.
Oh, this is one of his most fascinating, albeit flawed, biological assumptions. Tesla genuinely believed that a definite thought in the brain produced a corresponding reflex on the retina of the eye.
Wait, so he thought the eye wasn't just a lens taking light in, but more like a biological two-way projector.
Exactly. He hypothesized that since the brain processes an image, that mental image must cast a shadow back onto the retina. He thought we could eventually build a highly sensitive machine to photograph those retinal reflexes, project them through a lens, and play a person's thoughts and memories on a screen, like a movie.
Wow.
It sounds absurd to Victorian sensibilities, but when you look at modern fMRI machines today, they can literally reconstruct blurry images of what a person is looking at based on brain activity.
He was aiming at the right target, just with the wrong physiological mechanism.
Precisely.
And we can't forget his proposal for teleforce. The press dubbed it the death ray.
Yeah. In the 1930s, as the world was rapidly sliding toward the horrors of World War II, Tesla proposed a directed energy particle beam weapon.
He claimed it could shoot a concentrated beam of microscopic tungsten particles 200 miles through the air, capable of stopping massive armies in their tracks and melting the engines of fleets of 10,000 enemy airplanes.
But his reasoning for designing this terrifying weapon is what stands out.
Right, he didn't want it for conquest.
No, he envisioned it as an invisible Chinese wall of defense that every single country would possess. If every nation was completely impervious to physical attack, he believed it would make war entirely obsolete.
He actually tried pitching this defensive shield to the governments of the United States States, the United Kingdom, and the Soviet Union, hoping to prevent the looming global conflict.
No one built it.
So what does this all mean? When we look at this final list, thought-reading machines and directed energy death rays, it's easy to dismiss him as an eccentric old man losing his grip on reality.
It is easy, but this raises an important question about how we judge genius.
Right. Because given that militaries are actively testing directed energy laser weapons today, and neuroscience is decoding brainwaves with AI, we have to pause. When a man who already accurately predicted the smartphone, and who personally invented the alternating current power grid, the induction motor, and radio remote control, tells you he's figured out particle beams.
You listen.
Yeah.
His track record demands that we take those visions seriously. Even his later dynamic theory of gravity in 1937 lacked proof, but you can't just write it off.
Were these things signs of a man losing his grip, or was he just pitching a 21st century startup in the early 1900s?
I'd say he wasn't losing his grip on reality. He was simply living in a reality the rest of us hadn't evolved into yet. He operated on a timeline a century ahead of his peers.
A timeline he sadly never got to see materialize. The historical records detail a very quiet, heartbreaking end of his life. This is the man who literally gave us the modern electrical grid. But he died deeply in debt, living alone in room 3327 at the New Yorker Hotel. He spent his final years increasingly eccentric and isolated, his main companionship being the pigeons he fed outside his window.
It's a tough image to swallow.
He passed away in January 1943 at the age of 86. And the sources note that almost immediately upon his death, the FBI swooped in and seized all his papers, trunks, and research under the Alien Property Custodian Act, terrified that his death ray schematics might actually be real.
A quiet end to a very loud, brilliant mind. But if we want to talk about his true measure, his ultimate legacy, I think it comes down to that core difference we discussed at the start.
Products versus ecosystems.
Exactly. If you remove Thomas Edison or George Westinghouse from history, the business landscape of the 20th century looks different, certainly. We might have had different brands or different monopolies.
Sure.
But if you remove Nikola Tesla's foundational contributions, the AC grids, the induction motors powering our factories, radio communication, autonomous remote control, fluorescent lighting, you literally and metaphorically turn off the lights on modern civilization.
The entire machine grinds to a halt.
It does.
We owe him the glow of our cities, the invisible system humming beneath it all. Tesla saw that system before a single wire was even laid. And so, as we wrap up this deep dive, I want to address you directly, our listener, and leave you with one final thought to ponder today.
Something to mull over long after we sign off.
Look around at the hyper-commercialized world we live in right now, where every resource is metered, packaged, and sold. If a brilliant, visionary engineer like Nikola Tesla were alive today, and they walked into a boardroom pitching a technology that would fundamentally dismantle our current economic models, like a system for completely free, unmeasurable global energy, would our society actually fund them and let them change the world?
Or would they find their funding pulled?
Would they end up feeding the pigeons, too?